All right, let's start tonight off by hitting the record button so that we don't have that same mess. Um, that guy does a nice job of explaining stuff, though. So if you watched his video, that was the same exact topics that we had covered the first 40 minutes of his video. So real quickly, we will review what the integral test was from last night. And then we're going to hop back into this second packet and look at what a P series is. And this is not too bad. So just as before we do that, these tests start to build. So I'm going to try to, as we go through here now, try to start giving you a little bit of a flow chart of like ideas and things we can do, because especially over Zoom, I can see where this gets confusing. So the question that you always are starting with is something converging or is it diverging? And whenever you're asking that question, is your series doing one or the other? The first thing that we should always be looking at is we would start with the nth term test. And that was covered a video or two ago. But that's the easiest one to do. And we need to remember that this one only tells us if something diverges. So when you do that, that was when we looked at the limit as n goes to infinity for whatever series you're talking about, n equals whatever to infinity for a sub n. And then if it doesn't equal zero, then we said it was what? Diverging. And if it did equal zero, then we called that inconclusive. And then that means we need to further explore other ideas. So other things we had looked at, we looked at is something a geometric series? And when we were talking about geometric series, essentially a geometric series is going to be, we've got a summation from like n equals 1 to whatever, and then you have like a fraction in parentheses. And the thing is that this fraction, the top and bottom, would be getting raised to a power. And then depending on what this fraction is, this fraction was called the ratio. And if the ratio is a fraction, then we can say that this is going to converge. And to find the sum of a geometric series, I gave you the formula of first term over 1 minus the ratio. Okay. So that would be a next thing we could take a peek at. Last night, we looked at the integral test. And what do we know about the integral test? We said that you have to have something be positive, continuous, and decreasing. And if you can make those three, things be shown to be true, then the format for that was the summation of n equals 1 to infinity for a sub n and the integral from 1 to infinity f of x dx, either both converge or both diverge. And we learned some notation last night for whenever we're talking about this piece here. To write that out, this is, you're not allowed to use infinity in your bounds of an integral. So the trick for sidestepping that is we use a limit. So this would be the limit as b as in boy, approaches infinity, and that's going to be 1 over b f of x dx, 1 to b being your bounds. And then you got to go through and use whatever integration techniques necessary. It could be u substitution or inverse. Last night we had arctan or whatever. And if you can show that one piece of this either converges or diverges, then you've got a conclusion from there. Okay. After that, tonight we're going to look at something called a P series. So I'm trying to rewrite this a little bit for you guys, just to kind of summarize what we've done, because as we've been going through all these videos, it's pretty easy to kind of lose track of what's what. So that's kind of the main ideas of what we've been saying so far. So for right now, we're going to hop into a P series. We're going to do 4 and 5 tonight. We're going to add 2 more things to this list. So let's take a look at a P series. Okay. A P series is an infinite series in the form. Now, the big takeaway here is that the power is only on the bottom, whereas with a geometric series, that's the one where it's going to be on the top and the bottom, right? So like, in other words, I can't necessarily rewrite all of these. You have to have the number 1 up top, and this power is going to be consistent. Whereas the thing that's changing is the letter N. So N is going to be the thing that has the growth to it. And the power is always consistent. And the rules for this are, if P is greater than 1, it's going to converge. And if P is a fraction between 0 and 1, you're going to have something that's divergent. Now, that's a lot of words, but we want to see if that makes sense when we put it on paper. It should. And the other piece to this is there's a special name for if P is exactly equal to 1, that's referred to as harmonic. So before I go on, I'm going to just stay quiet for a second. You guys go ahead and copy. Okay, so are the following P series, and we're going to do a little more than just say yes or no to these. Let's investigate each one and see what we can come up with. So for letter A, is the following a P series? So my first question would be, can I rewrite this? So it's a negative exponent, so of course we can. So this is going to be the summation. Now they're using K here, so obviously letters are open to change, but you can kind of follow along with what's what. But if we flip this down, would it make sense to say that I'm going to call this K to the 4/5 power on the bottom, right? So now this does fit the pattern. So yes, this is a P series. And then go ahead and tell me some more about it. Since we have 4/5 as a power, does it make sense to you to say that this would also be something that diverges? Now, let's try to prove that to yourself. Let's pick a few numbers and actually run this through and see what we get. If I plug in 1, this is 1 over 1 to the 4/5 plus 1 over 2 to the 4/5 plus 1 over 3 to the 4/5. Okay, so this is really anything 1 to a power is just 1 plus, but now these are a little messy. But if you type these into a calculator, you're going to see that you have, so for example, let's use, you can't exactly do this by hand. Would have been better if I picked a example with nicer numbers for you. Let's see. If you type 2 and raise it to the 4/5 power, you've got 1.174. And 1 divided by that is looks like 0.57. Double check my math on a calculator as well for you guys. It'd be easier for me to prove this to you with numbers or that it actually have powers that work out. But the key that I'm trying to get to here is if P is greater than 1, this is considered converging. And if you have between 0 to 1, then you've got diverging. Okay. All right, let's have you guys tackle B, C, D. Let me zoom out a little bit. And E. See what you come up with. Okay, for this second one, this is going to be the same thing as saying the summation of n equals 1 to infinity, and this is 1 over 2 to the n. Now, that should be real tempting to say yes to, but we got to keep in mind what a p-series is, and that is that p, the power, is always the same thing, and the number in front of it is the one that's changing. So that's not the case here because your ticker is n equals 1. So as that ticks up and goes up and up and up, that power is the one that's changing there. So this is not a P series. So then the question you might have is, well, what is it? We can rewrite this as the summation of n equals 1 to infinity. And then we could say that this is a half raised to the n power, because 1 to the n is 1, and 2 to the n, that would go down to the bottom. And then in that case, this is really a geometric series. Okay. How about the third one? We can say that's what? That's the summation from k equals 10 to infinity of 1 over k to the fourth. So does that line up? We have a power that's consistent. The number in front's the one changing. Yeah, yes, that would be a P series. And more specifically, P is greater than 1. So we would say that that one converges. Okay. For letter D, absolutely not. And that one should hopefully be straightforward because what? We're just going to plug in numbers and this thing's just going to take off. So this would immediately, we could say that this diverges because as you just start seeing the numbers go in there, they're going to get bigger and bigger and bigger. You can also use what we call the nth term test. That's the limit as n goes to infinity for the summation. That's not equal to 0. Therefore, this diverges. Okay, and our last one. So this is the same thing as saying k to the first power. So this would fit the story. So the answer is yes. And now this was a specific case. What we have written up above, a harmonic series is a p series where p equals 1 and diverges. So this is yes, and it's a diverging harmonic series. Any questions up to that point, guys? Okay. It's like marker went through the page a little bit there, sorry. Okay, we've got 3 questions on this page, and we want to determine the convergence or divergence of the thing that you have in front of you. Determine the convergence or divergence of the thing that we have in front of you. Okay, so what I see is that this is really 1 over k to the 3/4 power. That fits the mold of a p series. And since this is a decimal, it's between 0 and 1, this would then be diverging. Okay. Let's take a look at the second one. So that one right there, we're saying, does this converge or diverge? And maybe to get a sense for what's going on here, you might want to try plugging in some values to see what happens. You can kind of see how it lines up. Okay, so if you start plugging terms into this, what are we going to get? We start with 4. So if I put 4 into this, this is 1 over 4 minus 1, that's 3 squared. And then if you put 5 in, that's 1 over 4 squared. And then 1 over 5 squared. So you can see that this is a p series, and in this case, p is greater than 1. So this would be a p series, and then we would say that this converges because p is greater than 1. Okay. And the last one.
I have a question.
Yes.
Do you have to, when you're giving y, do you have to say it fits this rule, or can you say we can see that it's slowly reaching, like the number you're adding slowly reaches 0?
If this was free response, I would make sure I state things such as It's a P series.
Okay.
P is greater than 1, therefore converges. I think those are the big key
Okay.
pieces of information that they would want to see. If it's multiple choice, then you would just do whatever to get to the right answer. And the last one. So here's our big difference in these. When the thing that changes is the power, that is not a P series. When it's a P series, the power is locked in, and the thing that changes is the number in front of it. Whereas in this problem, this E isn't changing, but the power associated with it is the one that's going to keep climbing and climbing. So in reality, this is the same thing as saying 1 over E to the K. And this goes back to now being geometric. And since my ratio is a fraction, 1 divided by E is a fraction, we could in fact find the sum of this if you had to. And the sum would be the first term, a sub 1 over 1 minus the ratio. Now, they're not asking you to do any of that here. I'm just elaborating, just kind of telling you the stuff that I'm picking out and seeing. So the first term here would be what? If we plugged in, looks like 2 is the first term. That would be 1 over, because this would really be 1 to the K over E to the K over 1 minus the ratio. And then you'd have to go from there and simplify and whatever. But that's the end of P series there. Does that make sense, guys? Because we're going to use that in a bit on this next lesson that we have coming up. Cool. All right. So let's take a breath from that, and as we jump into our third packet, let's do a couple quick review problems. And then today we're going to be doing direct comparison. This is our third packet in the sequence series stuff. Let's see. Let's do number 5. That's what we're up to. What is the sum of that series? So see what you can come up with there, and we'll talk in a second. The sum of that series. It looks like choice D got cut off too. It's not choice D, so don't worry about choice D. It's A, B, or C. See if you can rewrite this into something that would work for you. Okay, so if I want to make a summation out of this, first thing I'm going to do is say this looks like pi over E, and then we got to pick a variable for this. So let's just say like n equals 1 to infinity. So to me, that kind of summarizes this, right? So then if I wanted to, you can factor out numbers. So just kind of like we pull numbers out in front of integrals when we did U substitution, we can also do that here. And then that becomes this. And then once you have that, that's the same thing as saying, and now we're looking at something that is geometric. So when we go through and do that, it's going to be first term. So what is the first term? The first term is going to be, if you plug a 1 in, that's 1 over E, but then times pi. So it's pi over E is the first term over 1 minus the ratio. And then we got to clean that up and see what we get. So this is pi over E over, and then common denominator down there, we'll call that E over E minus 1 over E. So that's pi over E over E minus 1 over E. And then if we flip our four-story fraction, that's going to be pi E over E times E minus 1 and cancel my E's. And that's taking me to pi over E minus 1, which is choice C. Let's see. Let's tackle a polar question. Why not? What is the slope of the line tangent to the polar curve? This just seems like a question you'll definitely see on multiple choice. So things to remember are dy dx in polar land is going to be equal to dy d theta over dx d theta. And what else do we need to know? We know that y is equal to r sine theta and x is equal to r cosine theta. So when you derive y, you've got a product rule. When you derive x, you've got a product rule. And then go from there, plugging stuff in and see what you get. All right, answer. Anybody got anything?
I got pi over 2.
I have pi over 2 as well, so let me slide this over. So when you're doing this, you've got a product rule on the top and a product rule on the bottom, and then you got to go do some plugging in, and that should work itself out to pi over 2. So very good. Let's see. All right, we are ready to jump into this. So tonight's lesson is going to be on a testing method called direct comparison. All right, so we are going to be given something, and we're going to use, typically it's going to be a P series that we use on the other side of this, but we're going to let the thing we're interested in here, A of n is going to be between 0 and this one here, we can call this the comparison. And there's two situations that we can come up with. And basically, if B of n converges, then A of n converges. And if A of n diverges, then B of n diverges. Now, before you copy all that, and I'm going to have you copy it, but let me get a piece of scratch paper here. And here's basically the story. I'm going to use just these little curves. And let's pretend that that curve represents B of n. And then A of n is between 0. So here's 0, right? It's this line here. And that marker didn't have any ink left. Let's try blue. So between 0 and B of n is going to be A of n. And if B of n converges, that means it's heading to 0, right? Because all the terms are going to get super small. Just picture this as an animation. And to me, this is the way it'll make sense to me. If B of n goes straight down, it's going to smush A of n, and it's going to make it do the same thing, right? But if B of n goes skyrocketing, well, there's no action happening on A of n, right? It's just still chilling. It could be doing whatever. We don't know. But if B of n goes down and it converges, then A of n is going to get smushed in the process, and that's going to happen. So look at this definition. If B of n converges, then A of n converges, right? The easiest way to memorize that is just picture this little graphic. And now vice versa, if A of n converges, does that put any pressure on B of n? Does that make any action happen there? No, this just goes down and B is doing whatever. But if A of n would go up, then it would push B of n up with it. So if A of n diverges, so does B of n. So that's like the English version of what this rule is saying. If it does the other two things, this test doesn't do us any good. So if you can get through it with this test, then this is the options available to you through direct comparison. So if B of n converges, so does A of n. If A of n diverges, so does B of n. Okay. Okay, so let's check out this first problem. Yes, Harlow. So basically what we're saying is that they're going to give us a thing and we're going to compare it to a P series. So what we have to do is whatever problem they give us, we're going to find a way to put it between. So I'm going to go 0. That's going to be, now this one is what they gave us. Now I need to find something over here that's going to be bigger than this. So does it make sense to say 1/3 to the n is bigger than 1/3 to the n plus 2? Think about that. as your numbers get bigger on the bottom, the net result is a smaller answer, right? So that means this is bigger than this. Simultaneously, this is a P series. So we're going to be able to work with this and actually come up with some kind of an answer here, right? So I take that back. This is not a P series. I just lied to you. This is a geometric series. The power is changing over here. But now let's look at the comparison. So if I say, what is happening over here on this one? This is the summation from n equals 1 to infinity. And that's the same thing as 1/3 to the n. And what do we know about this? This is geometric. I see a ratio of 1/3. Bless you, Bronwyn. And that should tell me that what? Geometric ratio 1/3. Does converging make sense to you guys there? Okay, so now we just figured out that B of n converges. So what is my rule? If, remember, this is 0 less than A of n less than B of n. And then keep that picture in mind that I showed you earlier. Here's Bn, here's An. Okay, if B of n is converging, does that push action down on A of n? Yes. So this would work. And we could say, therefore, by the integral test, An also converges. Do we have questions there on anything? Feel free to yell out and talk to me, because this is some, you are into, if you're talking in terms of college calculus, this is deep into calculus 2. I mean, you're way, way, way out there in the college curriculum. So, I mean, this is not supposed to just be like, hey, derivatives. So if you've got a question, I mean, talk to me here. Anything, any part of that? Okay, so I've got one last problem on this topic for tonight. So we'll tackle this together. This one has a slight twist to it, not a big one, just a slight twist. Okay, so we're gonna try using our integral test. So we're gonna go 0, and that's gonna be less than or equal to. And then my first thought here is that we're going to have this, right? But does this help? Does this work? Well, let's find out. So remember our comparison. This is going to be 0 less than A of n less than B of n. So for this B of n piece over here, this is really now the summation of 1 over n to the half. And that looks like a P series, right? So it's a P series, and the fraction is the power. So this would be divergent. Okay, but now let's go back to my picture. Here's Bn, here's An. If B of n is diverging, did that put any action or pressure on An? Right. Okay. So yeah. So this didn't particularly help. So what else could we try here? We have 0. Let me see how we could rewrite this. Is there a way that got to come up with a way in our head of rewriting this? Let's see. we know that we have zeros on the left bound. And since this is my function, I'm going to put it over here. Now we need to like temporarily make something that fits in here. Just like over here, I temporarily made something. So I need something that's going to be smaller than this. Would it make sense to say that 2 plus n would be smaller than this? Because like, for example, say I plug in 4. This would be 1/6. 4 over here would be 1/4. That would make this smaller, right? Okay, so if we go through and we try the same game now, what do we have on our piece on the right here now, my Bn? Well, let's find out. If I did the summation from n equals 1 to infinity of 1 over, and then actually, I think an easier way, what if we just call this one right here? Because if I can call this one the summation of 1 over 2 plus n to the first power, that's a p series and the power is 1. And if the power is 1, that's harmonic. So I'm going to scrap that idea now that I'm sitting here. This is, if you're listening to me talking to myself, that's because that's the only way to get, like, this is so far past normal. Like, you got to be talking to yourself, having conversation, trying ideas. I mean, this is just a big conversation. So if I could see that this is harmonic and it diverges, okay, now what does that tell us? Now I've got the a sub n1 in the middle diverging. Does that put pressure on b sub n? If a sub n diverges, now you've got a winner. So then you could say, therefore, these are going to diverge by the integral test. Okay. Okay, so in terms of what we were talking about a little earlier, I told you guys that when we're starting these, we want to look at converging, diverging. We have the nth term test. We have geometric series. We have integral test. We just talked about a p series. What did we learn tonight? Let's recap. What did we learn about a p series? A p series is in the form n equals 1 to infinity of 1 over n to the p. And if p is greater than 1, it converges. If p is less than or equal to 1 to 0, it diverges. If p is equal to 1, that is called harmonic. And then after that, we looked at the comparison. And the comparison test is whenever we want to think of this little picture with Bn and An. So if you have 0 less than or equal to An less than or equal to Bn, two things can happen. If A of n diverges, if A of n diverges, so does Bn. And if B of n converges, so does An. Okay. Okay, and that concludes comparison test. So just some things. So I'm going to post this video. I don't think it hurts to listen to other people explain this. That guy that I posted his video last night, he does a super good job, in my opinion, of explaining stuff. So I'm not going to keep posting his videos, but his name is Professor Leonard. So if you just click on the video from last night, you can kind of tag right along. His stuff is in order pretty much with BC is like equivalent to Calculus 2 in college. So if you just go through his unit, I think last night's thing for him was 9.3. So, I mean, you can kind of just follow along 9.4. It's going to follow all these same topics. So if you want to watch an actual teacher at the board, you know, field questions from the class and stuff like that, this material is going to follow very, very close to what he was up to in that college class. But yeah, any questions there? All right, we're getting there. We are getting there. So that's almost the end of the third packet. We've got 3 more packets, but it's all going to be out there. We will have covered it all. So hope you guys are doing well. Hope you have a good week, and I will see you Thursday night, and we will pick up from there.
Thanks.